Good day and welcome to the Math Salon. I'm Dr. Newman M. Dixon and we will look at a topic related to differential equation. So the question today that we'll be looking at is a proof to show that if y is equal to cos of e to the x minus pi on 4, then y to the second derivative would be equal to y to the first derivative minus 6 to the 2x and y. So we are given this function y is equal to cos e to the x minus pi on 4, and we have to show that this equality holds. So this is given to us, and what we are left to do is to look for the first derivative because we need it here, the second derivative because we need it here, and the second derivative is just a differentiation of the first derivative. So once we have that information, we just have to plug into this equation and show that the left hand side is equal to the right hand side. So already we saw before that if we have a function of this sort and we have to differentiate, then we can apply the chain rule. So to apply the chain rule, we will need something like this. So the first derivative of x is subjected to be dy dx. But we see that the y is a function of x, and there are two functions involved here. There's a cos function and there's an exponential function in there. So in order to do that, we are going to apply the chain rule. And what is the chain rule? Yeah, it's simply, if I have to do dy dx, we will do exactly the same way I did the last time, is introduce a new function u, which will substitute the argument of the cosine function there. So if we call that u, then you see my dy is still here with the x there, and this u can normally just cancel out, but we will leave it there to make it beautiful because that's what mathematics is. So what we will do is, I would let this stuff here be u. So it means let u be equal to what is inside there. So this is my u. If that is the case, that means I can differentiate this u with respect to x. So du dx. This is a constant, it's a number, and the derivative is 0. So the derivative of this is just e to the x. If I have let this be u, then it means my y now is simply cos u. So this is cos u, where the u was replaced by this. So it means this second part of it, I can differentiate y with respect to u, because there's no x anymore there. It was replaced when I made the substitution. So dy du is minus sine u. We know, of course, that u will replace later on, but we'll do that at a later stage. I've had the two things that are required, so I'm just left to put it in here. So that means my dy du is minus sine u, this is it, and my du dx is e to the x, that is that. But sine u was never given to me. I made that in order to ease my work. It's like washing somebody's hair with shampoo before you start doing it. Yeah, you don't change the hair, but you make it more comfortable and easy for your work and also make it beautiful. So if that is the case, then I will replace my u here with what I actually did substitute. In this case, e to the x is here, that's the minus, and the sine u is written at the back, just to make it beautiful. So e to the x minus e to the x sine, I replace the u here with what actually I used. So it means my first derivative is minus e to the x sine e to the x minus pi on 4. The second derivative is just another derivative of the first one. So this is a derivative of the first one. Excuse me. If this is true, it means I will just differentiate this part here again. So this is a new function I have to look at when doing a second derivative. No longer this, because I've already gone one step. In order to do this, of course, I recognize that this is also in a similar form like this. So this part we can still apply our chain rule. But then I have two functions that are multiplied by each other. This function is multiplied by this, but this is a function of a function. So this part, we would repeat the chain rule, but because it has this other part, we are going to apply the product rule that we already saw. We saw last time that if I have two functions of a variable u and v, and I differentiate them, then that is u dv with respect to the variable for which those functions depend on, plus v du with respect to that variable. I already showed that once. We did something like this. duv dt, for example, is u dv dt plus v du dt. We will use that here. So if we have to do that, first what I do is I'm going to keep minus sign of this constant. So this part like this with this one will be constant. Then I have to differentiate this. E to the x, the derivative is e to the x. We already saw that earlier today. So this is e to the x minus sign that. Now I keep minus e to the x constant. So if I keep minus e to the x constant, then I will left to differentiate only the sign of that. Then I can do exactly what I did before. And that is simple. Simply differentiate this inner part, like when we let u be that, we did that, and we had e to the x. So this is the e to the x, multiplied by the function. Now it's supposed to be y is equal to sine u. If we differentiate sine u, it's just cos u. So that is cos u, but u is this. So I get that part of it. Of course, the hair is now being shampooed. We have to wash it off. To wash it off, to make it look more attractive, we write them in the neat form. So this stays as it is. Here, I have e to the x multiplied by e to the x. Because I have the same basis, I can add the powers. So x plus x is 2x here. So that's e to the 2x, and this is the cos, and e to the x minus pi on 4. So if I see this is the left-hand side of what I needed, that is it here. I'm left now just to check to see if this right-hand side would be exactly as the left-hand side. The right-hand side says I should take the first derivative of y, which is what we already had, minus e to the x sine of e to the x minus pi on 4, and that is it there. It says minus e to the 2x, that's the e to the 2x, and y, but y is given here. I just write it there. Cosine of e to the x minus pi on 4. And if you look at these two, they should be identical. In that case, we've proven that the left-hand side is equal to right-hand side. So if a function is given by y is equal to cos e to the x minus pi on 4, then y double prime must be equal to y prime minus e to the 2x y. Thank you.